Hi everyone, my work's presentation is titled Hydrochemistry and Presence of Emerging Organic Pollutants in Groundwater of the Urban Barcelona. This work was founded by the Unbiased and Urban Watt projects. The importance of studying these compounds is that it is known that they have an impact on aquatic ecosystem and human health, although most of them are unregulated. Actually, Barcelona's groundwater is used for cleaning streets and irrigation of parks and gardens, due to its bad quality. Nevertheless, in drought periods and due to climate change, it should be considered a potential resource of water for other uses like drinking water. The aim of this study was to identify the different inputs and processes controlling the hydrochemistry of these waters, with special emphasis on these compounds. Here is the study area. To the left we can see the topography of the study zone, and to the right the piezometry, where we can see that it mostly follows the topography from the Collserola range towards the sea, to the southeast. In the elevation map we can observe the location of the 30 groundwaters and 1 river sample collected on July 2021 during the dry season. As we can see in the Piper diagram, most of these water relative composition are mixed type, coherent with multiple sources or inputs common in urban areas. We group the samples in 3 groups according to the aquifer and hydrogeochemistry of the samples. The high zones are waters with relative low mineralization and more proximate to the natural recharge zone. The Barcelona plain waters have higher mineralization, longer residence time, and more anthropic inputs. These two groups present mostly oxidating conditions, while the Bessos group present reducing conditions and an important influence of the Bessos River. We selected 29 emerging organic compounds from a variety of pharmaceutical, personal care products, drugs of abuse, and industrial compounds. In the table, we observe the statistics of these compounds in the groundwater and river sample. Firstly, we observe that for most of the compounds, the river concentrations are orders of magnitude higher, since these waters of the river are mostly discharged from water treatment plants that don't effectively remove these compounds, while in the underground system, these compounds are degraded by different processes like natural attenuation. Some of these compounds were detected in all samples, like diclofenac, an anti-inflammatory, benzeglygonina, the principal metabolite of cocaine, and cotinine, the principal metabolite of nicotine, indicating that these products are of common use by the inhabitants of Barcelona. The highest concentration was detected for hemfibrosil in the aquifer and the river sample, that is a pharmaceutical drug for losing weight. To the left, we can see the detection frequency. This is the number of these compounds in each sample, and to the right, the total loading in each sample. We observe a similar behavior with the highest values located toward the Bessos River, which is consistent with an input of highly polluted waters from the Bessos River. We perform a factorial analysis in order to address the factors controlling the hydrochemistry of these waters. The results show 2 main factors. Factor 1 is saturated by the compounds that present higher concentrations toward the Bessos, so this factor was associated with river-aquifer interaction. Factor 2 is saturated by the compounds that present higher frequency of detection, so it was associated to sewage filtration, since this process is mostly considered as diffuse pollution. To establish the relations between these compounds and inorganic parameters, we perform the Pearson correlation matrix that indicates several correlations among these. We study each of them by bivariate diagram, where we identify 2 types of correlation or behavior. Most of them was due to an anomalous sample with reducing conditions like the graphs on the left, some of them associated to point source pollution. Also, we identified that Only we identify some correlation that only show good correlation considering only the Bezos group samples with reducing condition, the graphs on the right. Probably these compounds behave differently depending on the redox environment. So the conclusions are that the complex hydrochemistry of this water is a result of multiple inputs and processes in the underground system, from natural to anthropic. The distribution of these compounds, along with the factorial analysis, indicate that the main input and of greater magnitude is the river-aquifer interaction toward the Bezos River, followed by sewage seepage around the urban area. Probably there's a minor input from urban runoff. The redox condition is a first-order control on the behavior of these compounds. Areas with reducing conditions show generally higher concentrations and better correlation with some inorganic parameters like metals. And this is it. Thanks all.